So for our first Riemann sum example, we're going to find the Riemann sum for the function x cubed minus 6x on the interval from 0 to 3, taking the sample points to be right-handed endpoints and using 6 subintervals. So what's different today than what we did in the last lesson is now you're going to start to see areas that are not just above the curve. You're going to find areas that fall below the curve as well. So when we mark off this area, so it's telling us to use right-handed endpoints. So starting with that 6 subintervals, we need to calculate what that delta x is going to look like, just like we did in our last lesson. So our delta x is going to be the difference of our endpoints divided by how many subintervals that we're going to use. So our delta x is that each width of our rectangle is going to equal 1/2. So what does that look like on our graph? So if I count over every 1/2 rather than going every one, I have 1, 2, 3, 4, 5, 6 subintervals. Now just like yesterday, we're going to calculate the height using our right ends of our function. So you can see that that first rectangle is indeed above the curve. So that first rectangle is going to be an overestimate. Our second rectangle is also going to be above the curve. Here's what is different. When we make that third rectangle, that third coming from the right-handed side to the curve actually falls below the x-axis. So when it falls below the x-axis, that means that our height is going to have a negative value. So when we talk about the area, it's no longer going to be all positive like area should be. It's going to be a summation of the net area. Some of the area is positive and some of this area is going to be negative. If I continue graphing to the curve from the right-handed side, you see that really the majority of my area is going to show up as negative area. So if I really just kind of quickly mark off all which would be negative, this area down here is all going to give me negative values because the height or the value of that function is going to be negative. This area up here is going to remain positive. All right, now using that Riemann sum notation, using that sigma notation, I'm going to take right-handed endpoints and I want 6 subintervals. And my sigma notation is going to say that I'm going to start with my first rectangle and go through 6. This just compacts my notation for this function. My function is going to be x sub n, which we know is x cubed minus 6x, but we'll run it through x sub 1, x sub 2, x sub 3, x sub 4, 5, and then 6. Times our delta x, which we already calculated to be 1/2. Now, we're not just going to go ahead and plug in x sub 1 because x sub 1 takes us all the way to this rectangle here, where we want to catch that x sub 1 this time is going to be 1/2. Then x sub 2 is going to be 1, and then we will count by 1/2 from there. All right, so starting our first, I showed you yesterday how we can add all of our functions together and throw that delta x outside. So that's exactly what we're going to do. Using this sigma notation, this says I've got to take x sub 1 and I've got to throw it in there and rotate it to x sub 2. And I continue this process all until I get to x sub 6 times our delta x. All right, so We showed here that our x sub 1, our first rectangle, should be at 1/2. So I'm really plugging in f of 1/2. Then I'm going to count by 1/2 from there. F of 3/2, f of 2, f of 5/2 until I get to my rightmost endpoint, which is going to take me to 3, and then I'm going to multiply that by my delta x, which is 1/2. All right, so now it's just a matter of taking each one of these values and plugging it into this function using a calculator. So when I do that using a calculator, my f of 1/2 should give me negative 2.875. You can see that area is in the negative region. I'm going to add that to an area of negative 5 below the curve. I'm going to add that to f of 3/2, which gives me negative 5.625. And I'm just getting these values by plugging those 3/2, those x of 1 through x of n, into that function. Plus f of 2 is negative 4, plus f of 5/2 gives me 0.625. So that's the first area that falls above that x-axis. So that's the first area that's going to give me a positive value. Plus f of 3 gives me a value of 9. When I add all that together, I multiply it by my delta x, which is 1/2. After I find this sum, I find that that gives me a sum of negative 7.875, which visually I can see that my negative values are way more than my positive values. So my area should end up to be a net area of negative 7.875 times 1/2, and that's going to conclude with negative 3.9375. In upcoming lessons, we're going to actually calculate what that true area is by integrating from 0 to 3, but calculating the fact that these negative values should turn to be positive. For our Riemann sum area, it calculates our net area, so it gives us a net area of negative 3.9375 square units.